Hi, this is Janak Reddy Dubaka. Welcome to Gold Mine Physics Problems for JEE Advanced. This is lecture number 1 part 2. మనం part 1 లో ఒక 5 ప్రాబ్లమ్ డిస్కస్ చేసాం. ఈ వీడియోలో we are going to discuss some more problems. See here, in the shown figure, block is released from the position when springs were in their natural length. Maximum elongation in spring 2 will be. Here, springs are connected in series. Therefore, in series, resultant spring constant that K equivalent is equal to K1 K2 by K1 plus K2. Therefore, K equivalent is equal to 2K into K by total spring constant 3K. K gets cancelled. This is 2K by 3. But in a elongation in the spring, it is maximum when it is in extreme position, that is equal to 2 mg by k, but only for one spring unte ikkada 2 unnai kabatti k equivalent rayali, that is equal to 2 mg. K equivalent is 2k by 3, so 2 gets cancelled. Therefore, x max is equal to 3 mg by k. This is the total elongation. See, for example, in spring elongation is x1, spring 2 elongation is x2. Therefore, total elongation x1 plus x2 is equal to 3 mg by k. This is another equation. From this, we have to find out x2. See here, for both the springs, here mass m is added. That spring force equally shared between that one, means same force act on the two springs in series. Therefore, your spring force for both the springs is same. That is equal to F is equal to K1 x1, that is equal to K2 x2. Therefore, here K1 is K x1, K2 is 2K into x2. Therefore, x1 by x2 is equal to 2K by K, that is equal to 2. But you have to find out here x2. Therefore, from this formula, x1 is equal to 2x2. ఈ x1 is equal to 2x2 ని x1 plus x2 is equal to 3 mg by k లో సబ్స్టిట్యూట్ చేద్దాం. See, x1 plus x2 is equal to 3 mg by k. ఇక్కడ x1 అంటే 2x2. 2x2 plus x2 is equal to 3 mg by k. Therefore, 3x2 is equal to 3 mg by k. So 3 gets cancelled. Therefore, x2 is equal to mg by k. This is the elongation in the spring 2. Therefore, answer mg by k, answer A is correct. This is the problem number 1. Next one. See here. A vertical downward force F is equal to 4 mg is applied at a point P on the solid sphere of mass m, and R lying on the rough sphere of radius R lying on the rough horizontal surface. If the minimum value of mu for the pure rolling is 4 by n, then the value of n is. ఇక్కడ చూడండి, ఇక్కడ పాయింట్ P మీద ఎంత ఫోర్స్ యాక్ట్ అవుతుంది? F is equal to 4 mg. ఇది 4 mg యాక్టింగ్ డౌన్వర్డ్స్. అట్లానే ఇక్కడ నార్మల్ రియాక్షన్ ఇస్ ఈక్వల్ టు, దిస్ ఈజ్ ఈక్వల్ టు నెట్ డౌన్వర్డ్ ఫోర్స్. ఒకటి దాని వెయిట్ mg ఉంటుంది, నెక్స్ట్ 4 mg. దర్ఫోర్ n is equal to 5 mg. This is the normal reaction acting on the sphere. But here, when the force is acting here, due to this force, there is a slipping tendency in backward direction. When slipping tendency is backward direction, therefore here frictional force is acting in forward direction. Therefore here maximum frictional force, maximum static friction, Fs max is equal to mu into n, that is equal to mu into n is 5 mg. This is the maximum frictional force. See here, the sphere is in rolling motion. Rolling motion means it is due to rotational motion and also translational motion. Rotational motion is due to torque, and the translational motion is due to here translational motion. We have to find out the for which force it is in translation motion and for which force torque is acting. Therefore, due to torque in is rotational motion. కాబట్టి టార్క్ వల్ల rotational motion ఉంటుంది. అట్లానే హారిజాంటల్ ఫోర్స్ వల్ల అంటే ట్రాన్స్లేటరీ ఫోర్స్ వల్ల ట్రాన్స్లేటరీ మోషన్ ఉంటుంది. ఓకే, హియర్ if you want to find out the torque about this contact point, for this contact point, this is a force acting in downward direction and this is a perpendicular distance between this force and this point of contact. Another force, frictional force, also acting at this passing through the same point. Therefore, torque due to this friction 0, torque due to normal reaction 0, torque due to mg 0. Only torque due to this 4 mg. Therefore, torque tau is equal to I into alpha. Torque means force into perpendicular distance. Force is 4 mg. See, here perpendicular distance means this is the perpendicular distance. This is the distance r. Therefore, this becomes r cos theta. Therefore, here perpendicular distance is r cos 60. Therefore, this becomes r by 2. Therefore, torque is equal to force into perpendicular distance, that is r by 2. And here the moment of inertia we have to find out about this point. This is a tangent. Therefore, for the solid sphere, tangent moment of inertia is 7 by 5 mr square. 7 by 5 mr square into alpha. Therefore, this becomes here m gets cancelled, r square cancel. Therefore, here 2 gets cancelled. Therefore, alpha is equal to, when you cross multiplying, 10 g by 7 r. This is angular acceleration alpha. But for this sphere, the translational motion is due to friction. But the horizontal directional active force only friction. But friction valla translatory motion vastadi. But the friction F is equal to m into a. For pure translational motion, a is equal to r alpha. Therefore, F is equal to m into a ni r alpha and rastam. But what is frictional force here? Frictional force is equal to 5 mu into 5 mg. Therefore, mu into 5 mg, that is equal to m into r into alpha is 10g by 7r. Here mg gets cancelled, r gets cancelled. Here 5 2 times. Therefore, mu is equal to 2 by 7. But in the problem, mu is given as 4 by n. Therefore, 4 by n is equal to 2 by 7. This is 2 times. Therefore, n is equal to 7 into 2, 14. Therefore, n is equal to 14. Answer B correct. Next one. See here, a uniform chain of mass m, length L is released from the position shown in the figure. Force acting on horizontal floor by the chain at the moment when half of the chain has already fallen, assuming falling portion does not form heap. See here, on this horizontal surface, there are two forces are acting. One force is due to the chain already fallen onto the surface. Due to that chain, weight is acting in downwards. Therefore, here half of the chain means L by 2 is on the surface. One force is due to weight, that force mg by 2. Therefore, half of the chain mg by 2. Another force due to impact force. Impact force means when the chain is falling, here the total chain is not falling. The links in the chain falling one after one. Therefore, when the one link hit the surface, it comes to rest. Therefore, there is a change in velocity, means there is a change in momentum. Due to this change in momentum, the chain exerts some force on the surface. At the same time, ground also exerts the same force on the chain. That force is nothing but impact force. Therefore, first we have to find out that impact force. For this one, see, this is the chain of length L. For example, x length of chain is on the ground surface. Therefore, x length chain, when moves downwards from ear to ear, that x length is on the surface. For this x length, it is moving with velocity v is equal to square root of 2gx. If you consider a small portion here of length dx, mass dm. Here impact force I am taking F2. That impact force for variable mass F is equal to m into dm by dt. So F2 is equal to V into mass dm means mass per unit length linear mass density into length that part is dx by dt. Therefore, F2 is equal to V into m by L into dx by dt. That the total length, this remaining length L minus x is moving with the same velocity v. Therefore, dx by dt is v. Therefore, v into m by L into v, that is v square into m by L. Therefore, here F2 is equal to v means square root of 2gh, v square means 2gx into m by L. But here half of the length is on the surface. Therefore, I have to take x L by 2. 2g into L by 2 into m by L. LL cancel, 2 cancel. This is mg. This is impact force. Therefore, total force on the ground, that is F1 plus F2. Therefore, F is equal to 1 is due to weights mg by 2. Another one is impact force mg. Therefore, this becomes 3 mg by 2. Therefore, answer 3 mg by 2, D correct. Next one. Here, a vessel containing ideal liquid of density rho is made to accelerate in a vertical plane with an acceleration 10 meter per second square as shown. Value of pressure difference between points A and C. Here, this velocity can be resolved into two components. One is horizontal velocity, another one is vertical velocity. Here, this horizontal velocity 10 cos 37 degrees and this vertical velocity 10 sin 37 degrees. Therefore, here horizontal velocity AX I am taking. See, AX is equal to 10 cos 37. See, cos 37 is 4 by 5. Therefore, 5 ones are 5 2. This is 8 meter per second square. And vertical velocity 10 sin 37, that is 3 by 5. Therefore, 6 meter per second. Therefore, horizontal acceleration 8, vertical acceleration 6. See, pressure at depth h, that is equal to h rho g. This is the formula for when liquid is at rest. Means if the container is at rest. If container is acting or moving vertically upwards, this is vertical acceleration. In that case, pressure difference is equal to h into rho into g plus a. H into rho into g plus a. See here A and B. Therefore, at point B, pressure is more than A. Therefore, pressure difference between PB minus PA is equal to H into rho into, here H means here given as L. H is L into rho. But here effective acceleration, that is G into vertical acceleration, G plus AY. This becomes L into rho into G is 10, vertical acceleration is 6. Therefore, this PB minus PA is equal to 16 rho L. It is equation number 1. And next one, between B and C. For horizontal acceleration, pressure decreases in the direction of acceleration by rho LA. Therefore, here decrease in pressure is equal to rho LA. It is in the direction of acceleration. Therefore, here B is having maximum pressure than compared to C. Therefore, pressure difference between B and C, that is equal to rho into L is L. A means here acceleration, horizontal acceleration is AX. Horizontal acceleration is AX, that is equal to rho L. What is horizontal acceleration? 8. This is equation number 2. But we have to find out the pressure difference between A and C. Therefore, if you subtract equation 2 from equation 1, that implies, see, this is PB minus PA minus PB plus C is equal to 16 rho L minus 8 rho L. Therefore, here PB gets cancelled. This becomes PC minus PA, or I am taking magnitude. This becomes 16 rho L minus 8 rho L, that is 8 rho L. This is the pressure difference between point C and point C. Therefore, answer is C, rho 8 rho L. See, these are the problems from lecture 1 part 2.